So, as Alan said, basically, I'm the CEO of a company called Sfile Technology Corporation, which is a startup. I do startups. I'm a serial entrepreneur. Many startups underneath my history of what I've accomplished and things out there. And Sfile Technology is a new kind of company, basically, that is trying to leverage machine learning and high-performance computing and parallelized processing to be able to do some of the things that you just heard about in this past presentation. So we take data from networks, stores all over the place, email exchanges and things like that, and we also take data from these old-fashioned ways of pieces of paper and things like that and try to basically look and dive into this kind of data using machine learning to help us find inferences, classifications, decisions, and things like that to generate meaningful analytics. That's what we do. Now, what's unique about our company is we try to do these with an approach to actually bring it into economic scale so that anybody can afford it, so that we can leverage the power of cloud computing or highly condensed core computers and actually do these things in a very fast and economical way. And that's kind of really a philosophy of our company, is that we try to basically democratize high-performance computing for everybody. And in 2008, I was invited to Pumps and Pipes for the first time, and it was the other guy's toolkit presentation. Fantastic day for me. Opened my eyes to a lot of different things. I've had past experience in healthcare, helping solve some of the problems in healthcare where we're trying to take patient charts information and actually digitize it in some kind of form so we can actually extract content off of it for biomarkers, for billing purposes and things like that. And really tough. And what I was seeing happening at this conference here opened up my eyes to some of the things that I tried to solve back in the 90s and see if whether or not today we can actually look at it with a different approach. And my head just started thinking about that. More important, what I also was exposed to was something that really was underneath our nose, but I really wasn't paying attention to, and that's the fracking boom that was going on out there. It was really fascinating to me what the engineering efforts were occurring right now to help people understand where they can extract hydrocarbons out of the ground where it was in the past uneconomical, and today you could probably find some means to get it done. Now, of course, oil prices were going up to $100 a barrel. Things were looking pretty good. And me as a good entrepreneur, I want a piece of that. And so Pumps and Pipes really introduced me to a market I didn't even really think about before. And so, again, coming into new horizons, I thought about this. And this is a few Pumps and Pipes later, and I think, what can Sfile and other participants here do together to explore new horizons? That's a great statement. And so I asked the question of ourselves and met up with a few people here at Pumps and Pipes and asked them, hey, what kind of challenges do you have that we might be able to solve for you? I'll tell you what we do as a company. Let's see if we could take what we do and help apply to some of the problems that you're facing. And so in the oil and gas industry, I found a couple of challengers that said, okay, let's give you a try. And so we had an industry-leading data provider that says, look, we need to take publicly available drilling completion reports, and they got a lot of insight in them. These basically are the reports that operators file when they basically complete a well. They put them into public record, and that's a gold mine of insights that operators who are looking to optimize their own completions activity by mining other people's data, they could basically try to find some kind of recipe or understanding that they don't have to spend millions to discover on their own. So the challengers said, listen, we've already spent a lot of money over a full year, almost 2 years at this point, for a large team in nearshore data capture technicians. They're trying to convert. And all they had was 3% of the Texas Railroad Commission data set done. Problem they had is that they were running out of time and running out of money. It says, listen, can you basically take some of your machine learned approach, or more importantly, our natural language processing approaches, to see if you can actually do the job faster? Because the people weren't doing it, and they weren't doing it good enough. What they did receive was a lot of inconsistent, convoluted, just basically a bunch of data that really didn't make a lot of good sense. The clients that this provider was selling this data to really didn't like it, and so they needed to improve the quality of that data. I said, okay, let's see what we can do. Why don't we leverage our data science experts, our high-performance computing platform, and let's do a deep learning exercise on this stuff. Let's try to figure out what exactly is happening in this data. And so we sampled over 241,000 completion reports that this basically represented that 3% of the Texas Railroad Commission that was already done by human beings. So the result sets were going to be compared against that. We were going to apply some machine learning and natural language processing techniques and discover some patterns, we hope. Now, these challenges we did it for free because we're trying to understand exactly what the problems were in the industry. So we put our people on it and we said, let's go try to do that. And in the end, what we hoped to accomplish was a new artificial intelligence model that performed the work of those hundreds of operators. We need to do it in days as opposed to years as it was taking right now, because we were trying to save money. In the end, again, changing the economics of this, we needed to make it much more economical to get to those insights. Our discoveries were interesting. We had over 3 million word patterns in this data. Very inconsistent data. And those of you who basically are involved in oil and gas, you probably understand this. This is all that narrative information about fracking activity by stage, where people were using all kinds of short codes, acronyms, all kinds of things. A whole different language that only the oil and gas people know. More importantly, only the completions people only know. But we did discover something really interesting. We discovered unique patterns of speech within that. And we looked at this challenge a little bit differently. We came in and said, this looks a lot like some of the activities that we were doing in the past to try to identify chatter on the internet so we can find the bad guys, you know? They always talked in code, and what they really had is their own language. And if we could just understand the patterns of their language, we can decipher it, and we can understand what the bad guys are going to do. So we decided we're going to look at this completions activity as chatter, in which we had to figure out how to decipher that language. So in the end, we actually were very successful at doing that. What we really did is we took stuff like this. We called it unstructured data. If anybody's familiar with that term, what it really means is the stuff you write down on paper. The things that people do in their emails, free form, they put them in narratives. Doctors do it on top of charts. Engineers do it on top of their drilling reports, their completion reports. It's all this unstructured data that has insights, because that's the human's interpretation of what's going on. And sometimes when you're dealing with activities that involve nature, like humans and patients, like geology and the earth, where you can never predict what the outcome's going to be, you can never predict how they're going to respond to what you do to it, you can't really codify that data. You have to basically use a language of your own that puts short codes and capture that data. And so the only way that you can actually start mining that data is if you can figure out how to normalize all that data that all of these experts and specialists basically put on paper and bring it into a form that you can do comparatives with. And therefore, what we did is we went in here to learn how to do that, how to build spatial understanding of those relationships, and basically how to build a Rosetta Stone for completions activity, just like we did in the past for doctor's notes on small specific specialty activities. So in the end, we were able to actually go ahead and process all that stuff in 19 minutes when we built our models. It took us 6 weeks to build the models, 19 minutes to process all the data that all those hundreds of people basically took to get done. And our information itself was 94.8% of the items were actually accurate. We found a lot of noise that we couldn't understand. You're going to have that in some of these exercises. And more importantly, we found 1,355 normalized material names in this data that were ideal for making direct and indirect inferences to other people's catalogs or databases as well too. This engine could be trained to infer related information as well too. And it really was an interesting thing, because the real truth of the matter was, when we were talking about materials and activity, something like fracking at that time, there were really about 380 material names that we thought were really in the market, not thousands like the prior provider was actually getting out of everything. And so we took that challenge, and another oil and gas company around here has heard about it and says, listen, we have another challenge for you. Since you were so good at grabbing that data and actually making good sense of it, and you're able to process all that stuff. And by the way, we did finish the Texas Railroad Commission in 11 hours after that. So it was all done from that point forward. This challenger, another large oil and gas company, a national oil company that everybody probably knows their name, but I won't mention them. They needed new data models in order to drive actual insights. The challenger needed 65 data points that required highly skilled experts to read volumes of well files and build a database. This database basically was a completions database. They were looking at taking and mining all their non-operated wells, which are basically wells that were actually drilled and completed by other operators that were around the areas that they were interested in to identify whether or not they can find anomalies or patterns or whatever they do to find success. They needed these key insights and data points, and they were scattered all over various forms of semi-structured and unstructured data points in PDF files, Excel file formats. I was a little shocked that most of the data they were capturing and spending millions of dollars on was actually sitting inside Excel's, PDFs, and things like that. This data was also, whenever they try to capture it, The human operators always inconsistently interpreted that data differently. One person was subjectively thinking that one thing meant one thing and another thing meant another thing. A great example like slick water. Everybody knows that who's into fracking activity. Yeah, I saw different phrases for slick water as in SW, frack water, all kinds of different ways. As a matter of fact, I think we discovered about 400 different variations of how people refer to slick water, which is really something very common in these activities. So we have to figure out a way how to normalize these things in order for us to understand the context of what was happening inside these narratives as well. This operator had a lot of well files they needed backfiled, and it was really important for them because as the price of oil was dropping, they had to figure out quickly how to optimize completion activities so they can make it economical. So anyway, the other thing that was happening is they were ongoing, right? This is like a manufacturing process. They had 10 to 40 rigs in the field, constantly feeding more data. They had to know exactly what was happening. They had to basically collect all that data, which is the collective of all that experience, bring it into a system so they can actually analyze it and actually find out if they can determine what's more efficient and not efficient so they can save more money. So we leverage our data science experts, our platform again, we transformed it again. We looked at the same kind of way. We applied machine learning and natural language processing. Again, all this stuff was pretty interesting, but what I started to notice was how much their activity was looking a lot like healthcare to me. It looked a lot like a patient chart, and I said, why don't we attack it like a patient chart? There are a lot of interesting insights that we can find. So anyway, we kind of went through, built some workflows. Here's the data they gave us. Tons of this stuff. Actually, about 400 gigabytes of stuff like this is what it was. All this stuff with narratives sitting in between it. All these written notes. This is gold. All the stuff of what was happening in these narratives. Not simply in the columns and fields and everything else, but in the narratives. Because the narratives, just like doctors, that's where they see something that kind of, got it interesting. They note it, but they might have forgot it maybe 10 hours later or 5 hours later unless they go back to the chart. And that's the purpose of the chart. Well, back in well files, that's the purpose of them as well too. Every depth level, they do a narrative. At every hour frequency or some time frequency, they do a narrative. They basically are taking charts on their activities. And so we decided, okay, let's apply something that we've been building internally, which is basically we call IDP, or an Intelligent Document Processing Engine. What we've been building is an artificial intelligence library that learns how to read paper, any kind of paper, without even having been trained. It goes and learns and builds a model on that paper and learns how to find key value pairs and extract them very, very rapidly is what it was. So we thought we had a secret sauce here that we can actually attack this problem with. It does feature tagging, machine learning classifications, all kinds of stuff like that. And so in the end, what we did was we were able to basically put our engine on this stuff and make it into stuff like this in a matter of just seconds. Very, very, very rapidly. Now we have key value pair stores, things that we're very, very interested in because as a data analyst, I can deal with that. I can't deal with this unstructured stuff, but I can deal with this stuff right here much, much easier. And so now we were able to actually look at the data and see something, but we really weren't there yet. It was really still too difficult to get these 65 data points that this operator wanted for us. And we had to figure something else out because, like Google trained a car to drive, we trained a computer to read, but we now need to take the computer and teach it how to comprehend that content. We got to teach it now how to be a reservoir engineer, how to be a geologist, how to be a geophysicist, in a sense. And what we really needed, in the end, is we said, why don't we look at that like a forensic examination? And the thing that data doesn't have that's really necessary, and I think anybody who does any kind of data capturing, it needs time series to understand behavior. And so we wound up developing our own model of actually taking that data and transform it into a time series approach, which basically look at time for well details, operating details, drilling details, completion details, materials. We look at all of these activities and actually put them into a time series so that we can actually start understanding that data as you captured over time, what's happening. We're building a simulator of what happened in the past and then making inferences to decisions about what exactly we have. Characteristics, for instance. We are basically using categorization techniques to basically do these things. Capturing and creating data points. In the end, by transforming all that normalized data into time series set, we were able to create a machine learning model, which actually was able to do pretty good. We had a really successful story. We took that data and presented it back to the clients. And by the way, they failed to mention we were competing against 4 other engineering firms when we were invited to do this challenge. They were going to read this stuff with their experts, and they were going to create a database as well. It turned out that our data was over 328% better than any human team's effort, and over 225% more data was captured in it on that. In the end, we got a pretty nice contract for doing it as well, too. So we came up with another product we called the Sfile Discovery of Well Files. It was a high-performance computing system. It comprehends the content of well files, your paper files. We can read now entire well files off of paper roughly in about 9 minutes. It takes an engineer sometimes days to maybe in a week to read a whole well file and carry the database out of it. So it was a very, very important thing that we got. It wouldn't have been for pumps and pipes. It wouldn't have been for people like you who basically gave me this encouragement and says, hey, we could probably do something with you guys. We would have done things. And in the end, we can get things like this, comparatives for well files. Here you're looking at basically volumetrics of materials across stages of fracking activity. You can see things very, very quickly. We put it in there. So we put it into something like Elasticsearch and Kibana to start basically visualizing this data as fast as possible. And so things we were able to get out of it were very, very quick. We realized that the industry needed some different approaches. And we gave them a lot of different approaches, things that we do every day. But we say, why stop there? Well, let's combine it a little more. Let's do a little more things. Let's get some actual insights next. And now we're basically taking all this kind of data, public data, private data, non-ops data, all kinds of data, merging it all together and building machine learning things to help them build better recipes now directly from the data that we're mining as well. But none of that at all would have been helpful or doable if I wasn't encouraged by the things I discovered here at Pumps and Pipes. And so to this, it's a success story. Now we're really changing the economics of discovery, and we hope we can keep that activity still going on for years and years to come.
I'll take that. Good. Thank you, Frank. 15 minutes, and we'll give you a break, and then we'll keep